Greetings to everyone. My name is Sandhya, working as an assistant professor in the Department of Computer Science and Engineering in Marri Laxman Reddy Institute of Technology and Management, Dundigal. Today I am here to discuss about stack and queue data structure. Firstly, at the outset, data structure is nothing but organizing the data in an efficient manner. The reason for organizing the data is to access, manage, and use efficiently. And we have two types of data structures. First one is linear data structure. And in linear data structure, the data is stored in a sequential manner. Again, the linear data structure is divided into two types. First one is static and the second one is dynamic. So under static, we'll be having the array data structure, and under dynamic, we'll be having the stack, queue, and linked list. These are the linear data structures. And the second type of data structure is non-linear data structure. In non-linear data structure, the data is not stored in a sequential manner. And the examples for the non-linear data structure is graphs and trees. Under graphs, we have BFS, DFS. These are some of the examples for the graphs. And under trees, we have binary tree, binary search tree, binary tree, binary search tree, AVL tree, red-black tree. These are some of the examples of the trees which are used in a non-linear data structure. Next is stack data structure. As a stack is a linear data structure, it works on the principle of LIFO. LIFO stands for last in, first out. That means the element which is inserted at the last will be deleted at the first. That means, for example, this is a stack, and in stack there is only one end, that is top end. This we call it as a top end, and from this top end the insertion will be happening and deletion will be happening from the top end. So the last element, for example, if I insert an elements A, B, C, D, E, E, the first element which is inserted is A, and the next element is B, and the third one is C, and the fourth one is D, and the fifth one is E. Whereas from deletion point of view, the last element which is inserted into the stack will be deleted. So the element E will be deleted first, after that D will be deleted, after that C, after that B, after that A. Like this process will be happening in the stack data structure. Next is stack operations. The first operation in the stack is push operation. Push operation is nothing but the inserting an element into the stack. And next operation is pop operation. And pop operation is used to remove the element from the stack. Next is top operation is the third operation, and it returns the topmost element of the stack. And next operation is empty operation. It returns true if the stack is empty. Is empty operation returns true if the stack is empty, or else false if the stack is full. The next operation in the stack data structure is size. It returns the size of the stack. Next is stack implementation. The stack can be implemented in two ways. One is by using arrays and the another one is linked list. So by using arrays, we call it as a static implementation. As a static implementation is nothing but, as we know that array is of fixed size. So whenever we declare an array of 5, we can insert only 5 elements into the array. We cannot insert a 6 or 7 elements into the array. That's the reason we call it as a static implementation using array. Stack implementation using array is a static implementation. In array implementation, elements are stored in a fixed size array, and a variable called top is used to track the position of the last inserted element. And the next implementation of stack is using linked list, and this linked list is a dynamic implementation. As we know that linked list is a collection of nodes, and each node is divided into two parts. First part is data, and second part is pointer. So a stack can be implemented using a linked list where each element node contains a data and the next pointer to the next node. Next is stack applications, and the first application is function call or recursion. So here the function call refers to whenever the last function call is called in a particular program, the last function call will be stored at the top of the stack. And the next stack application is expression evaluation. Whenever we want to convert the infix to postfix or infix to prefix, conversion will be using the stack. Next is parenthesis checking. The parenthesis checking is the third application of a stack. Here it will be checking whether a valid parenthesis is present or not. Next is undo and redo operations. So undo and redo operations can be used by the stack. Next is reversing the data. Here reversing the data is nothing but whenever we want to perform a string reverse. So the string can be stored in the stack application. String reverse, for example, if I take a string of Geeta, and this Geeta will be, so whenever we want to insert this Geeta into a stack, first the G will be inserted, after that E will be inserted, after that next E will be inserted, after that T, after that H, after that here A will be inserted. So I want to perform a reverse operation. So whenever the reverse operation, as we know that stack follows the LIFO, that is last in first out. The last element is, here is A, and here it is H, and here it is T, and here it is E, and here it is G. So like that, when we pop, the reverse of the string will be performed. And the next application is depth first search. It is a graph traversals. Whenever we want to perform a depth first search, we'll be using the stack application. Next is queue data structure. Even the queue is a linear data structure, but it follows the FIFO, that is first in, first out principle. So as I said, in stack there is only one end, that is top end, and the insertion and the deletion, will be happening from only this one end. Whereas in the queue data structure, we have two ends, that is front end and rear end. So here the insertion will be happening from the rear end, that is insertion will be happening in the rear end in queue data structure, where the deletion will be happening from the front end. So the first element is inserted, is the first to be popped out in the queue data structure. And the queue operations, the first operation is NQ operation. NQ operation is nothing but inserting an element into a queue. So whenever if the queue is full, an overflow error will be occurred. Next operation is DQ. It removes the elements from the queue, and this remove will be done from the removing the element from the front of the queue. If the queue is empty, an underflow error occurs. The next operation is peak operation. It returns the elements at the front without removing it. The next operation is size operation. It returns the number of elements in the queue. Next is empty operation. It returns the true if the queue is empty, otherwise false. If the queue is not empty, it does not. If it is empty means it returns true if the queue is empty, otherwise it is false. Next is full operation. In is full operation, it returns true if the queue is full, otherwise it is false. Next is queue implementation. Similar to the stack implementation, the queue is also implemented by using arrays and the linked list. And the array implementation is, we call it as a static implementation. And whereas the linked list implementation, we call it as a dynamic implementation. In array implementation, elements are stored in array and two variables. Here in stack, there is only one end, but whereas in the queue we have two ends. That's the reason in the stack we have only one variable, that is stop, but whereas in the queue we have two variables, that is front and rear, that is used for insertion and deletion. Next is queue using linked list, and we call it as a dynamic implementation. A queue can be implemented using linked list, where each node contains a data and the next pointer. Here two pointers are maintained. For the first one is front, points to the first node, and the rear, which points to the last node. Next is queue applications. The first application is CPU scheduling. The first application is CPU scheduling, and the processes are executed in order they arrive, used in the it is mainly used in first come first serve. As we know that CPU scheduling is for executing the processes, so it is mainly the queue data structure is mainly used in first come first serve scheduling algorithm. Next application in the queue is printer queue. It prints the jobs that are stored in the first submitted job is printed first. The next one is breadth first search, and the queue is used in the graph traversals, and for depth first search will be using the stack data structure. For the breadth first search will be using the queue data structure. And the next application is interrupt handling, and the interrupts are processed in a sequence using the queue. The next application is ticket booking system. People in the line, it may be a railway or a movie ticket, it will follow the queue order. The next is types of queue, and we have four types of queue. First one is simple or linear queue. Second one is circular queue. Third one is priority queue. Fourth one is double-ended queue. Where comes to the first one, that is simple or linear queue. It follows the FIFO, that is first in first out, where the insertion takes place at the rear end and the deletion at the front. But there is a limitation. It suffers from the memory wastage when the space at the front cannot be reused. This is about a simple or a linear queue. The next one is circular queue. A circular queue is a type of queue in which the last position is connected to the first position of the forming a circular structure. Even it also follows the FIFO principle, that is first in first out principle, and it is mainly, the circular queue is mainly used to overcome the memory wastage problem of the simple or linear queue. The limitation of the simple or linear queue will be overcome by using a circular queue. And the third one is priority queue, in which the elements is assigned a priority. In priority queue, the elements will be having a priority. Based upon the priority, they will be executed. As we know that queue will be works on the first in first out principle, but whereas in the priority queue, the elements which are having the most priority will be executed first. Process are based on their priority rather than their order of arrival. It does not follow the FIFO. Instead, the elements with the highest priority is served first. The next type of queue is double-ended queue, and here in double-ended queue, insertion and deletion can be performed at the both the ends. Normally, in a simple or a linear queue, the insertion will be happening from the rear end and deletion will be happening from the front end. Whereas in the double-ended queue, the insertion and deletion can be done from the both the ends. Thank you.